Wormholes, reality or mathematics? Have you ever looked up at the night sky and felt a longing, a deep primal curiosity about what's on the other side of all that darkness? We see pinpricks of light, entire suns, galaxies spun like cosmic webs, but they are forever out of reach. The universe, in all its splendor, feels like a beautiful, inescapable prison. The distances are so vast, so unimaginably huge, that the very idea of crossing them seems like a fantasy. But what if I told you there might be a back door, a secret passageway woven into the very fabric of space and time itself? A shortcut, not just through space, but through time itself. Today, we're talking about one of the most enchanting, controversial, and mind-bending concepts in all of physics: wormholes. Are they a mathematical mirage, a beautiful ghost in the equations, or are they a real, tangible possibility waiting for us to find the key? Stick around, because we are about to embark on a journey to the very edge of reality. It all started not with telescopes, but with chalkboards. In 1935, two of the greatest minds to ever ponder the cosmos, Albert Einstein and Einstein-Rosen, were staring into the deep, elegant mathematics of general relativity. Einstein's great revelation was that space and time aren't just a static stage where the cosmic play unfolds. They are the lead actors. Space and time are a single, dynamic, flexible entity, space-time. And matter and energy tell space-time how to curve, while the curvature of space-time tells matter how to move. It's like imagining the universe as a vast, taut rubber sheet. Place a heavy bowling ball in the center, a star, and it creates a deep dimple. Now, roll a marble, a planet, nearby, and it will spiral around that dimple, not because of some mysterious force, but because it's following the curve in the sheet. Now, Einstein and Rosen, while exploring the solutions to these equations for something called the Einstein-Rosen bridge, found something peculiar. They discovered that the math didn't just allow for one dimple, it allowed for two. And these two dimples, these two gravitational wells, could, in theory, be connected by a tunnel, a shortcut through the rubber sheet of space-time, bypassing the vast, flat distance between them. This was the birth of the wormhole in scientific thought. But here's the crucial part. They weren't thinking about interstellar travel. To them, it was a way to describe fundamental particles. It was a mathematical curiosity, a ghost in the machine of the universe. It was elegant, it was beautiful, but they had no idea they were accidentally sketching the blueprint for the ultimate starship. Think about that for a moment. The greatest travel guide ever conceived wasn't written by an explorer. It was found as a footnote in the work of a theorist. It was a whisper from the universe, hidden in plain sight within the language of mathematics. So, what exactly is a wormhole? Let's move beyond the math and into the metaphor. Imagine you are an ant living on the surface of a giant apple. You want to get from the North Pole to the South Pole. The long way is to trek all the way around the equator. That's the conventional way we travel through space, across the immense, curved surface of the universe. But what if you had a way to burrow straight through the core of the apple? Your journey would be almost instantaneous. That tunnel you've created is a wormhole. It's a tube of space-time connecting two distant regions of the cosmic apple. Now, let's give this tunnel some structure. Physicists tell us a stable, traversable wormhole, one you could actually walk or fly through without being instantly obliterated, would have three key parts. First, there are the two mouths. These are the entrances and exits. They might not look like swirling vortices of energy as they do in the movies. They could be perfectly spherical, shimmering like a soap bubble reflecting entire galaxies on its surface. One mouth could be here, in our solar system. The other could be orbiting a star in the Andromeda galaxy, 2.5 million light-years away. Connecting these two mouths is the throat. This is the tunnel itself. The very nature of this throat is what defies our everyday experience. Inside, the geometry of space would be so warped that moving forward through the throat wouldn't be like walking down a hallway. It would be like the universe itself is flowing around you, carrying you to the other side. The walls of this throat might not be made of matter, but of pure, contorted space-time. Looking ahead might not show you a pinprick of light, but a full, wraparound view of the destination, as if you were already there. But to keep this incredible tunnel from collapsing, to stop it from pinching shut, like a rubber band, the moment it forms, you need something truly bizarre. You need a form of matter or energy with negative mass, or what physicists call exotic matter. This is where we step from the strange into the magical. Normal matter, everything we are made of, everything we see, has positive mass. It gravitationally attracts. It creates the dimples in our rubber sheet. But exotic matter with negative energy density would do the opposite. It would gravitationally repel. It would push space-time outward. In our wormhole, this exotic matter would act as the fundamental scaffolding. It would line the throat of the wormhole, pushing against the immense gravitational pressure that is constantly trying to crush the tunnel shut. It's the cosmic plumber's perfect tool, propping open a hole in reality itself. The problem is, we're not sure this exotic matter exists in the stable, macroscopic quantities you'd need to open a wormhole big enough for a person, let alone a spaceship. We see hints of its effects in the quantum realm. Strange behaviors at the subatomic level that suggest negative energy densities can bubble in and out of existence for fleeting moments. This is the famous Casimir effect. But capturing this quantum ghost and weaving it into a structural material to line a cosmic tunnel, that is a technology so far beyond our understanding, it might as well be magic. But here's the mystical question. Is its absence a statement of impossibility or merely a statement of our current ignorance? For centuries, we didn't know about radioactivity, about black holes, about the quantum entanglement of particles. The universe has consistently proven to be stranger than we can suppose. Perhaps this exotic matter isn't a thing to be found, but a state to be learned. A symphony of energy we haven't yet learned to conduct. Maybe the key to unlocking the wormhole isn't in a super collider, but in a new understanding of consciousness itself. What if the exotic ingredient is us? Our intention, our observation, far-fetched? Absolutely. But when we're talking about tunnels through time, all bets are off. This is where it gets even more incredible. Because space-time is a single entity. A wormhole doesn't just connect 2 points in space. It connects 2 points in time. Let's play with a thought experiment. Suppose we somehow master this technology. We create 2 wormhole mouths here on Earth. We keep mouth A stationary. We take mouth B and we put it on a spaceship. Thanks to the weird time-stretching effects of Einstein's special relativity, time dilation, as the spaceship accelerates to near-light speeds and returns, time will pass more slowly for the moving mouth. So, let's say the ship with mouth B travels for 10 years, from our perspective back on Earth. When it returns, only 10 years have passed for mouth A. But for mouth B, because it was moving so fast, only 1 year has passed. Now, here's the magic. The connection through the wormhole throat is instantaneous. If you jump into mouth A, 10 years after the experiment began, you would instantly emerge from mouth B. But Mouth B is only 1 year into its own timeline. You haven't just traveled through space. You have stepped 9 years into the past. You have created a time machine. The implications of this are staggering. It introduces all the famous paradoxes. The grandfather paradox. What if you go back and prevent your own birth? The universe, it seems, abhors a paradox. Some physicists suggest that quantum effects, or some as yet unknown law of physics, would prevent the wormhole from ever becoming a time machine in the first place, a concept called the Chronology Protection Conjecture. It's as if the universe has a built-in security system to prevent time travel, protecting the causal order of reality. But is that a fundamental law, or just a limitation of our current models? What if the universe allows for time travel, but in a way that doesn't create paradoxes? What if your journey to the past was always a part of the timeline? A closed, self-consistent loop. The very idea sends shivers down the spine, suggesting a universe that is not a linear path, but an intricate, woven tapestry where every thread is connected. Now, let's take this mysticism to its ultimate conclusion. If wormholes can be created, could they also occur naturally? Could the universe be riddled with them? A vast, hidden subway system of tunnels we simply haven't learned to perceive? Some of the most speculative and beautiful theories in cosmology suggest exactly that. What if at the very moment of the Big Bang, when the fabric of space-time was foamy and chaotic, countless primordial wormholes were woven into the very structure of the newborn cosmos? They could be microscopic, smaller than an atom, threading through everything we see and know. The space between you and your screen might be filled with a frothing network of these tiny tunnels. This leads to an even more incredible idea. What if these wormholes aren't just connecting points in our universe? The math of wormholes is eerily similar to the math that describes black holes. And one of the most profound theories about black holes is the holographic principle. The idea that all the information about what falls into a black hole is encoded on its two-dimensional surface, like a cosmic hologram. Now stretch that idea. What if our entire universe, with its 3 dimensions of space and 1 of time, is a holographic projection from the inner surface of a wormhole throat? What if every black hole in our universe is connected to a white hole, the theoretical other end, spewing out matter and energy into another universe entirely? Our Big Bang could have been the white hole end of a wormhole born in a parent universe. This isn't just science fiction. It's a serious, albeit highly speculative, area of theoretical physics. It suggests a multiverse, not as separate, disconnected bubbles, but as a vast, interconnected, mycelial network of realities linked by wormholes, a cosmic nervous system. We aren't isolated. We are a cell in an infinite, breathing, living superorganism of universes. So, we return to our original, haunting question. Are wormholes reality, or are they just mathematics? The safe, conservative answer is that for now, they are purely mathematical, beautiful, self-consistent, but utterly unproven. They are a dream, a map to a treasure that may not exist. But the human spirit has never thrived on safe answers. Every great explorer first had to dream of a world beyond the horizon. The mathematicians gave us the map. It's now up to us, the physicists, the engineers, the dreamers, to build the ship. The challenges are monumental. Finding or creating exotic matter, stabilizing a tunnel against quantum fluctuations, navigating a path through a realm where the laws of physics as we know them may break down. But the reward is the universe itself. It is the end of our cosmic loneliness. It is the ability to walk on worlds orbiting stars whose light hasn't even reached us yet. It is the chance to meet other minds, other life forms, not as a distant radio signal, but face to shimmering face. It is the power to see the birth of a star or the end of time itself. Wormholes represent the ultimate act of rebellion against the limitations of our reality. They are the promise that the prison of space and time has a key. We just have to be brave enough and clever enough to find it. The equations whisper that it is possible. The universe seems to allow for it. The only real question that remains is not can we, but will we? Do we have the courage to step into the shimmering mouth and see what's on the other side? The journey to an answer like that begins with a question. What do you think? Are wormholes out there, waiting? Or are they the most beautiful mirage the human mind has ever conceived? I want to hear your thoughts. Leave a comment below, and let's get a conversation started about the most incredible possibilities in our universe. If you enjoyed this deep dive into the cosmic unknown, if you love exploring the wildest edges of physics and metaphysics, then please help this channel grow. Give this video a like and subscribe so you don't miss our next journey into the mysteries of reality. We have so much more to explore together, and if your curiosity has been truly ignited, if you want to go even deeper down the rabbit hole of interconnected universes, holographic reality, and the true nature of existence, I highly recommend my book, Holographic Multiverse. We touched on the idea briefly here, but the book is a full-length exploration of this breathtaking theory. The link to purchase it is in the description below. It's a journey I promise you won't forget. Thank you for watching, for wondering, and for daring to look into the void and dream of a way across. Stay curious.